In this video, we're concerned with function notation. Remind ourselves that a function works like a machine. It takes particular input values, and the letter we use to represent inputs into a function is letter X, but any letter could represent that input. The F machine performs some operation to that value, and it produces some type of output, which we usually call f of x or y. Written in coordinate form, that is x comma f of x, this x stands for the input. Notice that x still stands for the input here. It's just that when you include the f with the notation, it means what the function equals when you use that input. And so this symbol altogether stands for the output. Now that means we have two primary ways of showing notation numerically with functions as seen below. So let's take this given function. It's an absolute value, 2 times the absolute value of x plus 1 minus 3. F of negative 5 is telling us, by giving us this f letter, it is saying we're referring to this machine that's been described up here. F has been defined for us. And we're concerned with trying to determine what f is when we have an input of negative 5. We could calculate that by simply replacing the x in our function with negative 5. F of negative 5 equals 2 times the absolute value of negative 5 plus 1 minus 3. Now, one thing I didn't do there, which it is often a very good idea, is to put your input in parentheses. That can help you sometimes avoid some order of operations mistakes. And we could simplify this. We'll want to do what's inside the absolute value first. 2 times the absolute value of negative 4 minus 3. When we take the absolute value of negative 4, we get positive 4, so 8 minus 3, which is equal to 5. So we find that f of negative 5 equals 5. Do keep in mind here with this absolute value, just a quick reminder, we always want to simplify an absolute value first, then take its absolute value. You do not want to change this into positive 5 plus 1 because of the absolute value sign. Now the second symbol, f of x equals 7, gives us a different piece of information. We don't know the input. But what we do know is that the output is equal to 7. So we know in this case what our function is equal to. We're trying to identify what number we could put into our function in order to produce this output. So this problem is solved differently. We instead want to take our function, absolute value of x plus 1 times 2 minus 3, and set it equal to our output so that we can solve. Add 3 to both sides, divide by 2. We always want to isolate that absolute value first. So the absolute value of x plus 1 equals 5. And here we'll hopefully remember our rules with absolute values that we got to split this into two different equations. X plus 1 equals 5 and x plus 1 equals negative 5 in order to get our two different values of x. X equals 4 or x equals negative 6. And those are the two different x coordinates or input values that will produce an output of 7. So I have created a few problems here. There are 3 functions. I'd like you to use these 3 functions to try and solve the 6 problems below. When you are done solving those problems, check the answer key, which is linked below, to make sure that you have solved them correctly.